Hello, Charan. How are you?
Fine, sir.
Good. So, have you done the question? Question
Which one, sir?
completed or not?
Which one, sir?
Mechanics question. The motion in 1D kinematic question.
Not completed, sir.
Please complete it. Right?
Okay,
This
sir.
chapter after relative motion, it will be completed, right? So, please complete the questions. Okay.
Okay, sir.
Yeah. All of you, please. Lokesh, you also. Please complete the questions. Okay.
Okay.
Right.
Sir,
Let's just wait for a moment.
came out from only
Yeah. Tell me.
sir, only Sangeet question.
Yeah, Singe's question.
One.
First of all, complete the Singe's questions. Okay, and after that, you can solve the HCV also. These two that will cover almost everything, and after that, I will give you some questions from the extra study material. Okay, so that question, some part you have to complete it at home, and some part you have to do it in the class also.
Okay.
Right, Manal, have you completed the questions?
Yes, sir, I'm
Kinematics
still doing
question.
it.
Okay. Please complete it. Okay, na? Please
Okay,
complete
sir.
it. Actually, let's continue now from here. Okay, so in the last class, motion under gravity we have done, right? Graph we have done, isn't it? From the graph, we have found out the area. From the graph, we have found it the slope, right? And this one question was for the integration method, isn't it? Differentiation and integration method. Okay. So based on that, another question we have discussed, isn't it? That what is the integration, when we should use the integration, when we should use the differentiation, these kind of thing we have done it. Okay. So now let's discuss the next part. Okay, so this question was depend for the velocity part. So here acceleration was given and they asked the position. So what we did, we just went backward. है ना? We used what? Integration to find out. And if position is given and then the acceleration is asking, then we should go forward. That means we should take help of the differentiation. Step by step, we have to take the differentiation, isn't it? So this is what we have done it till now. Okay. Please tell clear up to this.
Yes, sir.
Right. Now let's discuss about little bit about the relative motion also. Okay, so what is the relative motion? Tell me.
From looking from a
What
non-inertial.
does it mean by the relative motion? So relative motion. Relative motion,
Can be
non-inertial. It can be inertial
non.
also. It can be non. Tell me. Relative motion means from a moving observer, है ना? We are going to observe the motion of a body not with respect to a stationary observer. We are going to observe the motion of a body with respect to an observer who is also in motion. Okay, that other observer here, apart from the object, the observer is also in what? The motion. Is that clear? So, if the motion of a particle is observed with respect to any moving observer, then that motion is called as what? the relative motion. Is that clear? So relative motion, if we want to see what we can we say that if I want to write, see, let me take just one example here. Let's say this is the origin. Okay, this is the origin of coordinate system, and this particle B is here. Particle B is here. How much distance? Let's say something 10. I'm just taking a simple example. And there is another particle A here, and position of that particle is what? 5 meter. So if I ask you, what is the position of B with respect to O? So what you will say? Tell me. Position of B with respect to O. So what you will say? Will you say it plus 10, sir?
Yes.
Please tell me. And if I ask you, what is the position of A with respect to O? So you will say plus 5,
Plus
isn't it?
five.
But if I ask you, what is the position of B with respect to A? So now my observer is not O. My
OB
observer has
minus.
become what? Yes, OB minus OA. We can do it. Okay. So that means, can I say O is what? A stationary observer. And generally, the observer which is stationary is called as the observer attached to the ground. Okay. So generally, whenever I will write a stationary observer, we will take ground as a stationary observer. Okay. Or by default, if nothing is mentioned in the question, we can take the observer to be what? The ground observer. Okay. So can we say that one thing? Position of B with respect to A, will it be equal to position of B with respect to ground minus position of A with respect to ground? Please tell.
Yes, sir.
Isn't it? Same thing we have done. Position of B with respect to ground is 10. Position of A with respect to ground is 5. And if you write position of B with respect to A, that is coming 10 minus 5. That is the 5. Okay. So position of B with respect to A, can it be written as position of B with respect to some other observer? Okay. O is what? O is the ground observer here, and also position of A with respect to ground. So from the position, if I want to write velocity of B with respect to A, so what it will come? Velocity of B with respect to ground minus velocity of A with respect to ground. Can we write it? Tell me, velocity of
Yes, sir.
B with respect to ground minus velocity of A with respect to ground. And same way, if I want to write it, acceleration relation. So what we will write it? So if I want to
A.
write it, same method, exact same thing we will follow. Acceleration of B
Yes.
with respect to A, can it be written as B with respect to ground minus A with respect to ground? So this is the three thing we have. Okay, clear? Now tell me, if I want to know
Yes, sir.
one more thing, that what is position of A with respect to B? How much it will come? Tell me. And
OA
A
minus.
with respect to me means OA minus OB, correct? That means, can you say that it is nothing but position of A with respect to ground? OA is what? OA is position of A with respect to ground, na? And
Yes.
OB, that is the position of B with respect to ground, isn't it? So are you telling me that, sir, it is nothing but a position of A with respect to ground minus position of B with respect to ground? And if you look at these two things, please tell me, look at this one and look at this one. Do you find anything interesting between these two? Please check it.
Direction.
Do you find anything interesting here? So did you see that position of B with respect to A? Check it. Can you write it? Position of B, position of B with respect to A is nothing but minus of B with respect to A. Please check it. Means position of B with respect to A is same as the position of B with respect. Wait, here I have written same thing both the place. Position of B with respect to A, is it minus of position of A with respect to B? And if I want to compare the magnitude, so can I say magnitude is they are equal?
Equal.
Please tell, do you understand this thing? So
Yes.
magnitude wise, whether you calculate B with respect to A or you calculate A with respect to B, it's the same thing. So what is different in these two vectors? The direction of these two vectors is what? Different. Understand? And how do we understand who is my observer? So the one which is written last, that is our observer. Is it clear? Like if I write it something X, A, B, what does it mean? It means the B is what? It means B is what here? B is the observer. And what is the A here? It means A is the object whose motion I am observing. Understand? So please keep in mind the symbols that the first one is written as object and the second one is written as what? The observer. Please tell me, clear this one? So do we need to write it for same thing for the velocity part also or acceleration part also? Or is that clear? That can I do the same
Yes.
thing? Velocity of A with respect to B, will it be nothing but minus of velocity of B with respect to A? So it means if I know one of them, the other one can be 100% calculated, isn't it? The other one can be calculated automatically, magnitude wise, no change, and direction wise, opposite of each other. Clear? And if I again try to compare the magnitude of these two vectors, so can I write it? Velocity of A with respect to B will be magnitude wise, it is going to be equal. And same thing, the acceleration you repeat. Okay? So acceleration of A with respect to B is going to be minus of acceleration of B. Magnitude wise, again, okay, so these are not different things. Different. Find this just different things. I will get the velocity equation. Okay. Tell me, is this part is clear this part? Clear? Is this part clear?
Yes, sir.
Right. Okay. So let's take some example at how we the question on the relative motion, how we're going to solve. Okay. In this given to us that there is a particle that is with what velocity hello, please check it. Is it fine, audible?
Yes, sir.
Okay. So in the question, what is given to us? There is a particle A whose velocity is 5 meter per second. Its acceleration is given as 2 meter per second squared. And there is another particle B, its velocity is in this direction 10 meter per second. And its acceleration is also in this direction with 4 meter per second squared. Just find out two things here in this question, nothing more special. Find here what is velocity of A with respect to B And what is acceleration of A with respect to B? Please tell me what are these two.
Sir, we can't see your presentation.
Yeah, tell me.
Sir, we can't see your presentation.
Screen is not visible. Check it, all of you. It's showing screen sharing.
It's not coming, sir.
Yes, sir.
Okay, I will stop it and then we'll do it one more time. Yeah, check it now.
No, sir.
Yeah, please check. Is the screen visible now?
No,
Check it, screen sharing is showing. My screen is not visible. Please check it. Very strange. Is it visible now or is still not showing anything? Please, everyone.
It's not visible.
not visible.
Okay. Check once. Share screen. Just check it once.
No, sir.
Oh, it is possible. Okay. What is showing on the screen now?
So
Okay,
only
showing
videos.
on.
We can't see the screen.
Okay, let me rejoin it once then. Okay, let me rejoin and let's see. Check it. Is it okay now? Please check it. Is it okay now? Is it visible or not?
Yes,
Hello.
sir. Yes, sir. Now.
Now visible? Okay, so let's continue now. So this example is given to us that there are two particles, both are moving in the same straight line, okay? And the initial velocity of these two particles are given to us. and as well as the acceleration of these particles are given to us. Okay. And the question they are asking, what is the velocity of A with respect to B? And what is acceleration of A with respect to B? Okay. Please tell me, who is the observer here? A is the observer or B is the observer?
Sir, in first one, B is the observer.
Yes, B is
Both the
the,
cases.
yes, both cases what happened? Here, B is the observer being taken. So please tell me how much it will come. What is the velocity of A with respect to B will come? So before going to find out this thing, do one thing. You must consider one of the direction as what? The positive, isn't it? I'm going to consider this direction as the direction of positive vector. Okay. So tell me, velocity of A with respect to B. Can I say that velocity of A with respect to B will be A with respect to ground minus B with respect to ground equal to. Tell me, what is the velocity of A with respect to ground? Is it plus 5 minus? What is the velocity of B with respect to ground? Is it plus 10? So how much is that coming? Minus 5 meter per second coming. So minus is representing what? B will feel A to be left behind. Okay na? Matlab, with respect to, see, actually both are moving in the right side only na? See that? Both the vehicle is moving towards right only, moving in the positive direction only for a ground observer. But for someone sitting in the car B, how he will feel? He will feel that A is going behind. Why so? Because B velocity is more. Understood this one? Please tell me. So that is the meaning of this negative sign. What will be the acceleration of A with respect to B? So if I'm calculating, should I use it? A with respect to ground minus B with respect to ground. So how much it will come? A with respect to ground is how much? Is that minus 2? Please check it. A with respect to ground. Is it 2 meter per second square? But left side. So minus 2 will come. Minus. B with respect to ground is how much? Plus 4 na? So how much it will come? Minus 6 meter per second square. Please tell, clear this example?
Yes, sir.
Please tell me, clear this example?
Yes, sir.
Simple only, right? Actually, let's see the next example. Okay. Next example is what? That let's say a bus is there. Okay. A bus is there, and this bus is moving with what? Some velocity of how much? 20 meter per second. Okay. And you are standing here. How much distance? The distance between you and bus is given to us as what? 100 meter. Distance between you and the bus is given as how much? 100 meter given to us. Now what you did? You start accelerating. Your initial velocity is 0. Okay. Matlab you are starting from rest. And you are starting from rest and you have an acceleration of how much? 4 meter per second squared. So they are asking in the question what? Find time taken by a person Okay, the question what they are asking,
Sir, your voice is breaking, sir.
taken by the person to catch the bus. Catch the bus. Second thing, okay, to catch the bus. Okay, check it now. Is it okay? Let me keep the mic close.
Okay.
Okay, now. So in the time by person to catch the bus and distance traveled by person to catch the bus. Acha, we see in this question, what is really happening? This question is the bus is also moving
Yes,
and is
sir.
the bus also. So if we see from the graph, there is motion of two things happening. But if I see with respect to us, then what happens? Then we have to only look forward the motion of us. What I'm going to do, I'm all this question, and time has a very unique property. Time is what? It is independent of the frame of reference, is it? Check it. Is the screen sharing again got to stop? Check my screen visible again or what? Again the same problem. Is the screen visible or not?
Visible, sir.
Okay. So in this question, in the reality, what is happening? Bus is also moving and person is also moving. But for time is independent of the frame of reference. So that's why what we are going to do, we are going to see with respect to bus observer, what is going to be the motion of the particle or motion of the person. Okay. So tell me, with respect to bus, right? With respect to bus, what is the initial velocity of the person with respect to bus? Okay, initial velocity of the person with respect to bus. Tell me how much it will be. So what is initial velocity of the person with respect to minus initial velocity of bus with respect to ground? So tell me, what is the person initial velocity with respect to ground? Is the person has any initial velocity? No, to 0 minus. Bus initial velocity how much? Plus 20. Keep in mind, I am taking towards right as positive. Okay. What I am doing? I am taking towards right as what? The vector. Okay. So it means initial velocity of the person with respect to bus become minus 20 meter per second. Next, tell me, what will be the acceleration of person with respect to bus? So again, same thing I will write it, person with respect to ground minus bus with respect to ground. Person acceleration with respect to ground plus 4 minus bus acceleration with ground doesn't have any acceleration. Bus is always with unit velocity. I get plus 4 meters square. So please tell me, bus is then with respect to bus, how much person has to move? Please tell me. To move so that he will be able to catch the bus. Not respect to ground. With respect to different answer will come. With respect to bus, how much it should move? Listen, with respect to bus, how much it should move? Tell me. With respect to bus, how much the person with respect to bus what? Any person will feel how much distance travel the man or the person. Is that what is which is the gap between these two? Displacement of the person with respect to bus is 100 meters. That displacement of the with respect to bus is towards right. That's why plus 100. You see, initial velocity of person with respect to acceleration with respect to bus is known, and displacement with respect to bus is known. So three are known. Because this is happening just today only, right? Check the screen again.
Yes, sir, visible.
So can we apply this equation? Displacement of person with respect to bus, initial velocity of person with respect to bus, half acceleration of person with respect to bus, right? So here we are going by equation. Time we are going to apply the equation of forward, which is motion. Equation of motion for what? The relative motion. But this is relative acceleration. I can the value the displacement plus 100 initial velocity minus 20t plus half acceleration into t square. Simplify it. What I 2t squared plus 20t minus 100 equal 0. If you simplify square minus t minus just let me check it. There is nothing in your setting. Right. Let me just check it. Maybe did you had the other class also?
No, sir.
Today this is the first class or only class?
No, sir. I like 5 to 6 there is max class, sir.
Okay. Was it fine or any problem with the Zoom?
It was fine, sir.
Okay, it was fine. Okay, maybe some. Okay, let's finish this question and next thing we will do it in the next class. Okay. Let's finish the question. Is the screen visible? Hello.
Yes, sir.
Yeah, is the screen visible? Please check it once.
Yes, sir.
So t, if I'm going to calculate it, so it will come how much? T will come minus of minus 10 plus minus 100 minus 4 into 5, 50. So 200 divided by 2 will come. So that is coming 10 plus minus root 300. Na? So root 300 will become 10 root 3 divided by 2. So you see that one time is coming negative, one time is coming what? Positive. 5 plus 5 root 3 coming, and other time is coming what? 5 minus 5 root 3. So the next one is the negative time. So that won't be possible. Okay. We have to only consider what? The positive time here. Okay. So if we consider only the positive time, what will be the correct answer here? 5 plus 5 root 3 is going to be what? The correct time. Is that clear? Please tell me. This is the correct time. Okay. And other solution 5 minus 5 root 3, that will be not possible because that is coming negative. Once we got the time taken to catch the bus, can we also calculate it? What will be distance traveled by the person to catch the bus? So now we have to calculate what? So you will say, sir, distance already calculated, na? No. This is the distance traveled by the person with respect to bus to catch the bus. Okay, not with respect to ground. So if I want to calculate what is the distance traveled by person with respect to ground, then should I use it all the variable of the ground? Please tell me. Should I use all the variable of the ground reference now? Please tell. So with respect to ground, what is the initial velocity? So with respect to ground, person doesn't have any initial velocity. So that is 0 into t plus half. With respect to ground, what is the acceleration? Plus 4, isn't it? Plus 4. And what is the time taken by person to catch the bus? 5 plus 5 root 3 square. Okay, so what we are getting? 2 into, we can simplify it. 25 plus 75 plus 2 into 5, 6 into 5, sorry, 2 into 5, 10 into 5. So that is 50 root 3 we have, right? So what we have here, 2 into 100 plus 100 plus 100 root 3. So that much meter the person has run point. Okay. So sometime what happens now? Instead of looking at the motion of two different objects, we can see the motion of one object with respect to another one. Okay. We can see the motion of what? One object with respect to another one, and then we will be able to solve the question. Okay. Understood? Please tell me.
Yes, sir. Understood.
Yes, sir.
Right? That same question can be given in a little bit different statement form, like a police thief is there, police is there, thief is there, isn't it? The thief is moving with some velocity, and the police sees him and starts following. After traveling, how much distance the police will be able to catch? Right? Something like this. A thief car is there. Okay, inside the thief is there, and that is moving with what velocity? Isn't it? It will become the same one. Let's say this is moving with what? 20 meter per second. Okay. And behind, the police car is there. Okay. And that police car is moving with what? Let's say t equal to 0. There is a gap between them of 200 meter. Okay. And this person started with, or the police car started with some initial acceleration, not with initial velocity. Means initially the police car is at rest. When he see the thief, what will happen? He will start moving the vehicle. So its acceleration is given as what? 5 meter per second square. Okay, 5 meter per second square. Or sometimes what they will ask, sometimes they will ask you, this is what given to us. Now again they are asking the question, what is the time taken to catch the thief? Check it. Is it the same question or different question? Just name I have changed it. Right? Person has become the policeman. Car has become, bus has become the thief car, isn't it? Distance in this question, distance is given 100 meters. Now the distance is given as what? 200 meters. So check it. Is it the similar question? Just the storyline you can say that, or just the statement is little bit different than what is given in the last example. So please tell me, can it be done? Please tell me, can it be done now?
Yes, sir.
Right. So this question you can try it. Let's discuss another example. In this question, you are going to learn something. See, in the question what they gave, there is a train, or let's say there is a car. Okay, this is the car A. This is 5 meter long. Okay, and this is moving with what? Something 20 meter per second. Or let's take some smaller value. This is moving with what? 5 meter per second. And there is another car which is just behind it. Okay, this is the second car, which is what? Just behind it. And this car velocity is what? 10 meter per second. Okay, and let's say these two car length is how much? 20 meter given to us in the question. How much is the length of these two car? 20 meter given to us in the question. Okay, now they are asking how much time it will take to cross each other or overtake each other. Do you understand the question? Please tell me.
Yes, sir.
The question says the behind car is moving with 10 meter per second and the forward car is moving with what velocity? 5 meter per second. So this car will be able to overtake, na? Right or not?
Sir, what is the length of B, sir?
Let's take it same. Length of each car is what? Same. 20 meter is the length of each car given to us. So behind one, and there is no acceleration. Both are moving with what? Uniform velocity only. Okay. Both are moving with what? Uniform velocity only. Okay. So tell me, here, should we look at with respect to car A or should we look at with respect to car B? You can solve it with respect to any car. Okay. Now, so generally overtaking is taking place. So look at with respect to the ahead car. So here what I'm going to do it to see, I am going to see with respect to A what is happening. Means what? I am going to consider observer as which car? Observer as A car. That means, are you saying that you are going to consider A to be a stationary and then B has to overtake? Acha, can you tell me when the overtaking will be completed? Can I say, if I am considering, please keep in mind, if I consider, it doesn't mean that A is stationary. Please keep in mind. Here, it is just a problem solving approach, which gives us less calculation and easy understanding of the situation. Okay. This just gives us a little bit simple calculation, easy understanding, nothing else. Okay. So here you see I am writing the word considering A at rest. Matlab, whenever you put someone as observer, that means what? You are considering that particular thing as what? Rest. So if I consider A at rest, then can you say that when this B will be reaching somehow here, then can I say the overtaking will complete? If A is stationary, think like that. If this pen is stationary, if this pen is stationary, when I will be able to cross this pen? Now, can you see the diagram? Tell me. Can you see the diagram? I'm here right now. I want to cross. What I will do? I will start moving. Now the crossing is complete. Na? Overtaking is complete. Na? But if this pen is also moving, I am also moving. This pen is also moving. So a little bit difficult to see that. What I am doing to calculate the time, I am considering A at rest. Then this is how the overtaking will be completed. So tell me, considering A at rest, what is the displacement of B with respect to A to complete overtake? How much B will move if B has to overtake, right? Considering A at rest. मतलब displacement of B with respect to A for overtaking, how much is that? Is that actually 40 meter? Please check it. This is 20 meter. This is another 20 meter. Can I say that? Plus 40 meter. Please tell me. Do you understand displacement of B with respect to A for overtaking to complete is going to be plus 40 meter. What is initial velocity of B with respect to A? The initial velocity of B with respect to A, will it be equal to initial velocity of B with respect to ground minus A with respect to ground? What is B with respect to ground? Plus 10 minus A with respect to ground plus 5. Do I have plus 5 meter per second? Please tell me. Now tell me, what is the time taken? So can I say that displacement of B with respect to A should be equal to initial velocity of B with respect to A plus half. Acceleration to nothing there, zero part. That means, can I say that how much time that will take to overtake each other? Means how much time B will take to overtake A? It will take 8 seconds. Understood? Please tell me, do you understand this time calculation? How much time
Yes, sir.
B is overtake A? So that part is simple. Next time asking another thing. Tell me, what is the displacement of B with respect to ground? I am asking. What is the displacement of B with respect to ground? It's going to be initial B with respect to ground into 80 meters. So in question careful. Okay, let's ask in this question. And then ask you what is the time taken. So very simple. Find it. What is the displacement relative? Initial velocity relative. If I leave out and time. Okay, using equation. Next, they will ask it. What is the displacement of B with respect to after we have 80 meters? What is the total is in the what is the total length total length? Do you understand the question? What is the total length on the road used in this overtaking process? Please tell me. The total used is let's finish it here. Okay. right? Let's see. I think there may be some issue. Okay. So this part, please try to solve some questions now. Okay. See, mechanics part, now you can finish it almost everything except the relative motion sum of the question. Okay. So my request is that please complete all the questions sincerely. Okay. Because without practice, understanding the subject is very difficult. Okay. So please practice the question. Okay. Any doubt is there? None of you are asking any doubt in the class. Huh? Are you solving the questions? Please tell me.
By tomorrow we will complete, sir.
Right. So tomorrow, Friday, Saturday, Sunday, right? These 3 days we are going to have the electrostatics part, right? So before we start the next mechanics class on Monday, please complete all the questions of what? Kinematics 1D. Okay. Please tell me, all of you will complete or not?
Yes, sir.
Tell me. No response.
Yes,
We'll complete.
Please complete it. Okay. That I'm only telling for your betterment. Okay. Because that is the only way we all are going to improve it. Okay. Now, only with the help of the practice of the questions. Okay. So we'll try to discuss all type of questions in the class, right? But you also practice it by yourself so that when you solve the questions, you will come to know that what kind of difficulty you are facing in solving the questions. Okay. So practicing the question is very, very important. Okay. Without that, there is uh, not, you can say that much improvement without practicing the questions. Okay. I hope everyone will do the questions. Please tell me.
Yes, sir. Yes, sir.
Great. Okay. So let's meet it tomorrow, same time. And hopefully this problem will be sorted out because just today it started happening like that. Never faced something like that. Okay. So let's meet it tomorrow. Okay. Right, everyone?
okay. Thank you.
Right. Thank you so much. And good night, everyone. Keep practicing the questions. Okay.
Okay.
Right then. Take care. Good night. Okay. I will close this one. Then